Good morning. I'm Tong Kuiyun from National Chengchi University. The title of my speech is Information Aggregation in Big Data, Wisdom of Christ or Stupidity of Hertz. It is co-authored with my boss, Professor Shuheng Chen and Dr. Colin Wang. Why we do this work? The big data are changing our lives dramatically, but the impact of this information convenience to the society level decision quality is still not quite clear. Some people argue that more information may lead to better decision, which is called the wisdom of Christ. However, some other people argue that more information leads to people following the others, and this may lead to the cascading failure in society decision making, which is called the stupidity of Hertz. In this paper, we use the agent-based modeling to study the underlying mechanism of information aggregation from the individual's behavior. Based on the mechanism, we will investigate the impact of the big data to the check and balances between the wisdom of Christ and the stupidity of Hertz, and the resulting decision quality. Our work is based on the Warren model. We will first briefly introduce this model and highlight the main results, and then we extend this model to study the big data effect. There are unequal 100 agents in the society. In every period, the agents need to choose one of the two products to consume. These two products are released at each period, totally newly, different, independently from period to period. The expected value V of an item is a random number from a uniform distribution from 0.25 to 0.75. And an agent actual utility from consuming the item is also a random number from the uniform distribution from V minus 0.25 to V plus 0.25. This means the utility the agent can experience is from 0 to 1. And the value of the items in one period is completely independent from the early periods. The agents make decisions sequentially, one after another, and the order of the agent to make decision is random. The agent has no information about the value of the price. How will they make the choice? So the first agent can only choose by Toshi and Co. randomly choose one. And the late acting agents can observe the choices and they experience the utility of early acting agents. So the second agent can observe what the first agents do and how much utility he experienced. And the third agent can observe both the first and the second one. But the number of observations is up to 6. If there are more than 6 early actors, an agent can only randomly choose 6 out of them to observe. How will an agent make a choice after observing the choices and the utilities of 6 other agents? They use the strategies. Each agent managed a strategy pool with 31 strategies, as listed in the table. The first strategy is highest average, means that an agent will choose the item providing the highest average utility in the 6 observations. And the highest average 2 means choosing the item with the highest average besides this item must occur at least twice in the 6 observations. Another important strategy is the majority, means the agent chooses the item that the majority of the agents choose. And the following last strategy choose the same item at the last observation. And there is also a random strategy, which means randomly select one of the items, each with the equal probability. How the agent choose the strategy, which strategy to use. Each strategy is assigned a score measuring how good it is. The strategy with the highest score will be used in each period. We must notice that each agent manages his or her own strategy pool by himself or herself, so different strategies may assign different scores to the same. Different agents may assign different scores to the same strategy. After each period, each agent will update the scores of the applied strategy. If the strategy provides higher utility, the score will be increased. If the strategy provides a lower utility, the score will be decreased, which is called the reinforcement learning. Here is the main result of the Warren's model. The horizontal axis is the periods. The vertical axis is the success frequency, which the success frequency is a point. There's 1 point for each period. The vertical axis is the success frequency. Success frequency means the ratio of agents in one period. There are 100 agents, and some of them make the right choice and some of them make the wrong choice. The ratio of the agents making the right choice is the success frequency. We can see from the figure that at the agents learning period by period, the average decision accuracy is increasing. The average decision accuracy is increasing. However, the big failure probability, which means that most of the people make the wrong decision, as indicated by this figure, these points in the lower right side. This means the big failure, that most of the people make the wrong decision. So we can see that as the agents is learning, both the average decision accuracy is increasing. However, the probability that most people make the wrong decision is also increasing. So the wisdom of crowds and the stupidity of herds coexist in this model. And after a long period, the society will reach a quasi-equilibrium with that, which means that the average, the accuracy, the success frequency, the distribution of the success frequency reach a relative stable state. We extend the Warren's model to study the big data effect to decision making. Big data play 2 roles in information aggregation, as our understanding. The first is to increase information processing ability, that is, to enable us to observe more information. The second function is to enlarge the search scope, that is, to enable the agents to access information within a broader range. Firstly, we study the effect of the observation capacity. The observation number is fixed at 6 in Warren's model. To investigate the effect of big data's observation capacity in large room, we simulated with the observation number from 6 to 30. This is the result. The horizontal axis is the observation number. The vertical axis in the left figure is the mean of the success frequency at the equilibrium after the society reaches a relatively stable state. And the right side, the big failure, is the probability that most of the people make a wrong decision. We can see that as the observation number is increasing, the mean of the success frequency is increasing, and the probability that most people make the wrong decision is decreasing. So, if the big data can enable us to observe more facts in the world, more information in the world, the wisdom of a crowd be enhanced, and the stability of the herd can be diminished. Secondly, we will study the effect of the big data to enlarge our search scope. Another function of big data is to enable agents to access information with a broader range. In variance model, agents can access information in a global scope. In order to investigate the search scope effect of big data, we extend the model to a simple structure. We assume agents are located in a ring structure 1, 2, 3 to 100 and connected to 1. The search scope R of agents R ranges from 3 to 49. An agent with search scope R can only access the information from R range in both sides. So there are two R. The access range is totally 2R in both sides. And we also assume the observation number is fixed at 6. So if the potentially observed number is 2R, is larger than 6, so they only choose 6 of them randomly to observe. Here's the result. The horizontal axis is the search scope. How many agents I can access to observe, but I only observe 6 of them. And the axis is the search scope. The vertical is the mean of success frequency. We can see that the average decision accuracy increases first and decreases later after the search scope reaches a threshold about 20. How about the big failure or the stupidity of herd? The probability of the systematic decision failure keep increasing persistently as the search scope increasing. As a result, the society is absolutely worse off after this threshold because the wisdom crowd is decreasing and the stupidity crowd is increasing. Because the search scope reflects how many agents can be connected to. This result implies that a moderately connected rather than completely connected network is preferred from the viewpoint of information aggregation. Here's the conclusion. By an agent-based simulation model, we found that the individual of crowd and the stability of herds can coexist. If big data can enable us to observe more facts in the world, the wisdom of crowds can be enhanced and the stability of herds can be diminished. However, if the observation capacity is limited and fixed, a moderately connected rather than completely connected network structure is preferred for the society level decision making. There is also plenty of room for future work. That's all. Thank you.